Okay, here we go. Video lesson number 3. We're going to do a practical example here with some values in a 3-branch parallel circuit, and we'll throw in a little bit of power explanation in here as well. Okay, so part of this lesson, what we want to talk about is using the reciprocal method for solving for our RT. Okay, so we've got R1, R2, and R3 of 10 ohms, 6 ohms, and 15 ohms respectively. We have here from page 148 in your textbook a very good example of how to use the reciprocal method on your calculator. Very important. Also, it shows the 1 over x button here. Your calculator might have the x to the minus 1 button, which you will utilize as well too. Okay, so these numbers are actually fairly simple to work with, 10, 6, and 15. And from the previous video, we could just go ahead and find the common denominator. Reciprocal method is basically doing that type of thing with your calculator, putting it into a decimal and finding the reciprocal. If the numbers are not easy to work with, then using your calculator is a much better method. All right, so let's just punch this in here and see what we've got. All right, so we're going to go 10, 1 to the x, plus 6, 1 to the x, plus 15, 1 to the x. I hit the equal sign. It's adding them all up, and then I have to hit the 1 to or the x button again, and I get the final answer of 3 ohms. Right, and so that is perfect because I know that's what it was. All right, so our RT is 3 ohms. Okay, in this example now I've got, at our total, I have 2 values here, so I can use Ohm's law, and I can solve for ET using Ohm's law, which should be RT times IT, multiply the 2 together, 3 times 5, and I've got a grand total of 15 volts. Okay, I know parallel circuits, one of the characteristics are that the voltage is equal at all branches, so I can plug the 15 volts in each branch, and now I have 2 values in each branch, so I can use Ohm's law again. All right, nice easy numbers to work with. I know that's 1.2. This is 1.5 amps, 2.5 amps, and that one is 1 amp, right? And you can see then also double checking here that the sum of all the current flows in each of the branches should equal the sum, so I can double check that. All right, by adding 1 amp, 2.5 gives me 3.5, plus 1.5 gives me 5, and that verifies with our total current of 5 amps. So always a good idea to do a double check like that, make sure that all the numbers add up. All right, especially with current, because with resistance you got to use the reciprocal method. Okay, so that works out perfectly. Okay, so one thing we haven't talked about yet is power. Okay, the nice thing about power, regardless of whether it's a series circuit, a parallel circuit, or what's coming up in next week's lessons are the combination circuits, the power just adds up, right? So the power dissipated or used by any resistor, they just all add up to the total power consumed by the circuit. All right, so we can solve by each of these by using Ohm's law. Okay, power is one of the easiest formulas, ET times IT. So let's do the PT. We got 15 volts times 5 amps gives us 75 watts in total. Plug that in. Okay, and we can go ahead and do each of the other circuits. E1, oops. Check that. We're doing P. P1 times I1, right? Always taking the values from the same part of the circuit. 15 times 1.5, 22.5 watts. P2, E2 times I2, 15 times 2.5 is going to give me 37.5 watts. And the last one's easy. It's 15 times 1 will give me 15 watts. All right. And we can double check by adding those up. All right, so we have 22.5 plus 37.5 gives us 60, plus 15 gives us 75, which is what our power total of 75 is, so I can double check there again. Okay, so that is a quick example of how to solve a common parallel circuit with finding the total resistance using the reciprocal method, and then Ohm's law to solve the different branches, and double checking with your laws of parallel circuit regarding current and power.